Okay, so in this video we're looking at Newton's third law of motion, and as part of that we're going to recap Newton's first and second law of motion and then have a look at different scenarios involving Newton's third law of motion. Bring any questions you have to the next lesson and use the pause button. So let's recap Newton's first law of motion first. Here's a car on a road. It is travelling at constant velocity. Can you draw the forces acting on the car? Have a go now, press pause and then have a look at the answers. So we should have weight, normal reaction force, thrust pushing the car forward, and drag or air resistance opposing the motion. Now Newton's first law says that if the forces acting on an object are balanced, so if the resultant force is zero, then a stationary object will continue to be stationary, or an object moving at constant velocity will continue to move at constant velocity. So here with this object, this is moving with constant velocity, but the resultant force is zero, the forces are balanced, and so it continues moving at constant velocity. Now, for Newton's second law, what we can do is we can take that a step further. If we know the sizes of these forces, we can work out the magnitude of the resultant force, and then we can use F equals ma, from Newton's second law, to find the acceleration for that object. So we use the resultant force and the mass of the object to find the acceleration. In this case, the resultant force is 0 newtons, so the acceleration is 0 newtons. So next we're going to look at Newton's third law. Now Newton's third law is a bit different from Newton's first and second law because it's not looking at the forces and acceleration acting on one object, it's looking at why a particular type of force acts. So for example, if we think about the weight acting on the car, why does that weight act on the car? And the answer is because there's another object exerting that force on the car. So if we zoom out a bit, and we imagine that the car is on the earth, and we draw the centre of mass of the earth, there is going to be a force of weight acting upwards on the earth exerted by the car. Now this, to start with, can seem quite counterintuitive, but essentially what we're saying is that for force to be exerted on an object, it has to be exerted by another object. So if a force of weight is going to be exerted on this car, there has to be another object exerting that force, and that force in this case is the earth. But it also means that this object exerts a force on this object as well. So the earth is exerting the force of weight on the car, and the car is exerting the force of weight on the earth. Now, there's a couple of characteristics that Newton's third law pairs of forces have. So Newton's third law says whenever two objects interact, the forces they exert on each other are equal and opposite. And it's important to remember when you're looking at a situation and trying to identify the objects and the forces, that the third law pair of forces are the same type of force. So in the previous example they were both weight. They're going to have the same magnitude, they're going to act in opposite directions, they're going to act on different objects, and they're going to act in the same plane. So that just means opposite each other, parallel to each other. But really, really important point to remember here, they act on different objects, they are the same type of force. So let's try and identify the third law pair for the normal reaction force that we had acting on the car, because third law pairs apply to all of the forces. So an object is exerting a normal reaction force on the car, and the car must be exerting the normal reaction force on that object, and that object is the ground. So we can see that there is a normal reaction force acting through the wheels of the car, so that the ground is exerting a normal reaction force on the car, and the car is exerting a normal reaction force on the ground. They are the same type of force, they're all normal reaction forces. They act in opposite directions in the same plane. They are the same magnitude and they act on different objects. So this satisfies all the criteria for Newton's third law pair of forces. Now, Newton's third law has loads more exciting applications than a car driving on the Earth. And one of the most exciting ones is space rockets. How does a space rocket take off? And it's all to do with the thrust that the spaceship is getting from the exhaust gases. In this case, the exhaust gases are the other object. So, see if this video works. Watch the video. What you've got in the video is you've got a whoosh bottle experiment on some digital scales, and the reading of the digital scales is shown here. So we've coated the inside of the whoosh bottle with a flammable liquid, and then we're going to set fire to it, and you can see we've got lots of safety precautions we've taken here. And as the exhaust gases come up out of the top, you'll see the force exerted on the electronic scales changes.
Oh my god, that was screamed!
Now what's really important, if we have a little think about the third law pair of forces that are acting on the whoosh bottle and the rocket, we have got a force of thrust acting on the rocket going upwards, but we have got force of thrust acting on the exhaust fumes acting downwards. The exhaust gases are exerting a force on the rocket, and the rocket is exerting a force on the exhaust gases. They are the same type of force, they're both thrust, they act in opposite directions, they're equal in magnitude, they act in the same plane, but they act on different objects. So this is our third law pair of forces here. So in conclusion, forces of the same type always act in pairs, third law pairs. You'll never get one force acting by itself, there's always a third law pair of that force. The same type of force, same magnitude, opposite direction, acting on different objects in the same plane. Those are the criteria to check that you've got the correct third law pairs. Always run through them when you're trying to identify them. And this is different from finding the resultant of all the different types of forces acting on one object to find the acceleration. So bring any questions to the lesson and go back through the video again if you think it would help.